So we are now moving forward towards understanding the fundamental theorem of calculus. And the fundamental theorem of calculus is just very super important theorem in calculus, in integral calculus, I should say. It connects integration and differentiation, and it enables us to find integral values using antiderivatives of the function rather than having to calculate a Riemann sum, which is long and tedious. So before we understand the fundamental theorem of calculus, we need to understand the mean value theorem for definite integrals, because part of its logic is embedded in the fundamental theorem of calculus. So here we have the mean value theorem for definite integrals. If we have a continuous function on some closed interval a, b, then somewhere on that interval at, say, a point C, we can find that the function value is equal to the average value of the function. So in our last video in this series, I talked about that average value. That's the definition of average value. So this is just saying that f of c is equal to that average value of f. And so what the mean value theorem for definite integrals asserts or tells us is that that average value is always assumed somewhere, at least once, by the function on that closed interval. So let's think about this geometrically. I have brought a picture in here. And the mean value theorem says that there is some value c on your closed interval between a and b such that the rectangle with a height, this height, which is equal to the average value, right? That height is equal to the average value of f, and with a base that is a width, the difference of those intervals, b minus a, that the area of that rectangle is equal to the area under my curve on the same interval. And you can kind of visually see this. If I were to cut this little extra piece on the top here off and flip it around and plug it in here, it would be exactly equal. So the area of that rectangle is exactly equal to the area under the curve. So let's do a brief example that kind of illustrates this. It's going to be a pretty or rather abstract example. So here we are given an integral of a continuous function f of x on a closed interval a, b. And we know that the output, the value of that integral from a to b of f of x, integrated with respect to x, is equal to 0. And we also know, since a is not equal to b, that this is a non-zero width. It's not a zero width integral, which means we are doing it over some space. If a was equal to b, there would be no width between them, and automatically that value would be equal to 0. So we want to show that the function value, this is what we want to show, the function value is equal to 0 at least once on that interval. So in order to do this, we are going to calculate the average value of the function. And if we can show the average value is equal to that function output, 0, then we can say this will be true by the mean value theorem. So my average value formula, the average value of f, is going to equal 1 over b minus a times the integral from a to b of f of x dx, which is 1 over b minus a. And of course we know that that integral is given. This value is equal to 0. So it doesn't matter what b minus a is, regardless of that fact, the average value of this function will be equal to 0. And that's all we needed to say. So what does this mean visually? You know, thinking about this a little further. If we have some function on some closed interval from a to b, well, there is going to be some curve here. There's a c value in there. where we're crossing the x-axis, where my output is equal to 0. And that this area, if we look at the area under the curve, we add up these two shapes, the area of those regions, that would also be equal to 0. So that it's just saying that this is a possibility.